So today is day 3 of SQuInT 2016. It is the last day of the conference, and it is a Saturday. So it is currently 8:10 in the morning. I am consuming my first cup of coffee for the day. This stuff is very much necessary for academics to get work done. It is super, super great. So no videos from yesterday because I was giving my talk and I was a little bit concerned about saving space on my phone for my talk. So we will have a video of the talk up online hopefully sometime soon, probably within the next week or so. I need to sit down and edit the audio and the video and whatnot. So today is kind of a hodgepodge of ideas. I'm very much looking forward to the talk from Seth Lloyd from MIT, who's going to discuss, quote, quantum algorithms for topological data analysis. I spoke with Seth yesterday some about this, and it seems very sophisticated and very interesting, and perhaps a good problem where quantum computing could really help things along. We're also going to hear some about superconductors. These have been a really big, I don't want to say driving force, but there's been a big push to develop very robust quantum information processing architectures, and superconductors, amongst other architectures, are really gaining a lot of traction and getting a lot of good development. I think this afternoon we talk about atomic, molecular, and optical physics from an experimental standpoint. So this is going to be stuff about trapping atoms or nitrogen vacancy centers or other such things. And then finally, this evening, we're going to hear from John Preskill, who, being one of the founders or grandfathers of quantum information, I should say, is giving a keynote talk entitled Our Quantum Future, which should be really cool because if you haven't been following the science news, we recently discovered, well, by we, I mean the LIGO team recently discovered gravitational waves. And while I don't fully appreciate some of the nuances involved, I think that there's somehow, using quantum optical ideas in order to get the sensitivity of that device sufficiently low such that they could detect gravitational waves was something that they had to do. So on the whole, it should be a good day. I am feeling a little bit tired. So yesterday I gave my talk between 6 and 6:30 p.m. and then we had our banquet from 7:30 until 9:30, more like 9ish, I guess. And then I hung around chatting with people until about 10:30 and then had to go drive home and get to bed. So we're going to be a little bit more subdued today, I think, and probably take more notes and whatnot. I was unable to record a video at the end of the conference yesterday because, well, reasons. So I figured I would take a little bit of time today to talk about what happened yesterday. So yesterday was another very intense day of talks. We heard some stuff about, broadly speaking, quantum computation and quantum tunneling and how we might be able to harness sort of quantum behavior to speed up computations. And Seth Lloyd from MIT gave a very thought-provoking talk about how we could use quantum computers to do so-called topological data analysis, which is apparently a field that attempts to ask what is the geometry and what is the shape of this massive set of data that we're working with. And Seth's talk was pretty cool because he doesn't use PowerPoint, and so he has very nice hand-drawn slides that you just put up on the screen. And I should say they're projected to the screen as a PDF. So that was pretty cool. And I also heard some experimental talks, which was really fruitful. And this is one of the great benefits of SQuINT, is they bring together both theorists and experimentalists in a pretty nice blend so that I can get a sense of what's going on in the experimental world and experimentalists can get a sense of what theorists have been thinking about. So I saw that apparently well, not apparently, I saw that you could use these Schrödinger-Cat coherent states to do quantum error correction, which is interesting because my own work right now touches upon characterizing continuous variable quantum systems. So I thought that was kind of a nice connection that I should think about. And we also had someone from Google come and give a talk about variational quantum eigensolvers, which you use to determine, say, the energy configuration of a molecule or something like that, which then allows you to do other chemical analyses as well. The highlight of yesterday was really John Prescoll's talk. So he gave the keynote, the last talk of the conference, and he touched upon the topic of our quantum future. And so, if you don't know much about John, I would encourage you to go read his website and go read some of the stuff that he's written on IQIM's blog, quantumfrontiers.com, because it's just really fascinating how John, sat between quantum gravity and learned about quantum information, and a lot of his research recently has been about how can we synthesize these two and how can we really use quantum information to address and answer some of the pressing questions in the field that kind of have eluded us for a very long time. And so John's talk was very optimistic, and it said that we really need to dream big, because quantum computing could be something that really does revolutionize how technology and how technology works, and also has interesting scientific consequences as well. This notion of maybe space-time is some kind of quantum error correcting code, that's pretty cool. So John gave a very, very good talk, and it was very, very well received by the audience. So now after the conference, I went out for dinner with some people, and one thing about conferences is, as I've said earlier, you shouldn't try to go to all the talks. You need to pace yourself. And what you can do when you're not in listening to the talks is you go talk with other researchers. You say, hey, what am I doing, or what are you doing? And we see if maybe there's some interesting overlap or whatnot. And so going out to lunch or going out to have dinner with people is a great way to, one, meet new people, and then two, continue to develop the social relationships you have with people you already know. So that was pretty cool. So overall, SQuInT was a very, very intense conference. I mean, it's only 3 days, and there's a lot that's crammed in. We had talks from roughly 8:30 to probably 6. Yeah, I would say 8:30 to 6 or so. Okay, maybe 8:30 to 4:30, but just there's a lot of stuff going on, and there's a lot of content, and it's really cool that the SQuInT organizers this year were Akimasa Miyake and Francisco Elohim Becerra, and it was really cool that they were able to put on this good conference and bring everyone together. So I'm very much looking forward to SQuInT next year, and hopefully we'll make some videos of that then. So I guess this sort of concludes the series as it were about SQuInT 2016. And if you kind of want to follow along or look through some of the tweets, there were 2 hashtags. One was SQuInT16 and the other was SQuInT 2016. The reason for the discrepancy is that this is actually the 18th SQuInT conference, and so there was some hesitation that it might be confusing to use SQuInT16. So take a look at that on Twitter, and you can learn all about the conference. You can also check out the conference's website, which can be found at squint.org. Yeah, squint.org, and you can learn more there. So we'll talk with you later.